And number 5, on the left hand side, what's this equal? This is equal to, we got some trig on the right, sine x plus 4 cos x on the right there. The auxiliary equation here, 4m squared plus 4m plus 5 equals 0. Sticking that in the calculator, that's going to give us that gives us imaginary answers. It gives us a complex number minus a half plus or minus I. That tells us that the complementary function is e to the minus a half x, and then we've got a cos x plus b sin x. Going on from there then, let's think about that. Yeah, so the right hand side is a piece of trig, so we're going to start with a lambda cos x plus mu sin x. That's what we can try. Dy by dx, differentiating that, goes to the minus lambda cos x plus mu sin x plus mu cos x. And differentiating again, we get minus lambda cos x minus mu sin x. Substituting all of those into the original, we've got 4 of those, and 5 of those, haven't we? So we've got minus 4 lambda cos x, minus 4 mu sin x. We've got minus 4 lambda sin x, and plus 4 mu cos x. And finally, we've got 5 lambda cos x and 5 mu sin x. And we want that to equal sin x plus 4 cos x. So let's look at the sin x's then. So we've got minus 4 of them here, minus 4 lambdas there, and 5 mu's there. So that's minus 4 lambda plus mu equals 1. And looking at the cos x's, we've got 4 cos x's, don't we? So we've got minus 4 lambda plus 5 lambda, so that's just lambda, and then I've got plus 4 mu equals 1. So solving that simultaneously, that's going to give us mu equals 1 and lambda just equals 0. So the answer is the complementary function from earlier. So that was e to the minus half x, a cos x plus b sin x. Then we also need to add a lambda of sin x, so plus 1 sin x. So there's my general solution for all of that, and we're still not finished because we've got to now find out what it actually equals. So we're told that y and x are 0. When x is equal to 0, y is equal to 0. So we've got 0 equals, so e to the 0, so that's 1. That's 0, and so that's a cos x. So that tells me that a is actually going to equal 0, doesn't it? And when x is equal to 0, dy by dx is equal to 0. Does that mean I've got to differentiate that bit there then? Let me just think about that. It does, doesn't it? So differentiating up there, differentiate the first bit, e minus a half e to the minus half x, lots of a cos x plus b sin x, plus e to the minus half x. I'm trying to write smaller so it all fits in, and the a cos x, that's going to go to minus a sin x plus b cos x, and also got the sin x, which goes to a cos x. I just really can fit all this in at the end there. And when x is equal to 0, we know a is 0, so we can get rid of those. So we got 0 equals minus a half. That is b, that's 0 because that's a sine. So we've got, actually, at the end there, we've just got b cos x. So that's b plus 1 equals 0. So I think after all of that, I've got b equals minus 1. But it's been a 5-minute video to get there. My answer, can I squeeze it down the bottom here, is e to the minus a half x times by minus 1, so minus that, sine x, plus the extra sine x on the end there. Is that right? Minus a, yeah. Okay, got it.